Greetings, everyone. Thank you for joining the latest WAPOR webinar, this on risks and opportunities in the use of big data. I'm Gary Langer, I'm your moderator, and I'm here to tell you about Trent Buskirk, our presenter today. Trent is a distinguished professor of data science at Bowling Green University, State University, just finishing a stint as chair of the Applied Statistics and Operations Research Department there. He's been a leading survey methodologist, survey statistician, and data scientist for many years. In past lives, Trent has served as director of the Center for Survey Research at the University of Massachusetts, Boston, vice president for statistics and methodology at Marketing Systems Group, and as professor of biostatistics at St. Louis University. His work on survey methodology has been published in many leading journals. Trent's a fellow of the American Statistical Association, past conference chair for WAPOR, past president of WAPOR's Midwest chapter. He's an associate editor for methods for the Journal of Survey Statistics and Methodology, and a methodological and statistical consultant for a variety of research organizations, including my own. So Trent will present to us today on opportunities and peril in the use of big data, and an area in which he's focused a good part of his work in recent years. We're expecting about an hour-long presentation, and then we'll have about a half hour for questions and answers, which you can post in the chat, and I'll read out for Trent. With that, let's welcome Trent Buskirk.
Thanks a lot, Gary. I'm going to start sharing my screen, so hopefully everybody can see. We'll go forward here. Is it working?
Looks good.
Okay. Thanks a lot again for having me, and the webinar is really exciting to be here. Love our friends all over the world who do survey research and try to keep up the good work globally. So thanks a lot for coming, and we really appreciate your time. I thought we'd start with a disclaimer. 3 men are in a hot air balloon. Soon they find themselves lost in a canyon somewhere. One of the 3 men says, "I've got an idea. We can call for help in this canyon, and the echo will carry our voices far." So he leans over the basket and yells out, "Hello, where are we?" They hear the echo several times. 15 minutes pass, then they hear his echoing voice. "Hello, you're lost." One of the men says, "That must have been a statistician." "Why did you say that?" The reply, "For 3 reasons. He took a long time to answer, he was absolutely correct, and his answer was absolutely useless." I really hope today's webinar will find some utility in the work that you're doing and thinking about expanding data sources and sort of looking at the challenges and opportunities that exist in big data and doing this from a sort of holistic perspective. So today I'm going to talk a little bit about some big data sources that I think you might have already been aware of, but really maybe make their definitions a bit more formal, talk about some validity issues related to big data writ large, and then think about some examples where big data has been used or at least experimented with, and so on, to really help sort of expand the needle a little bit in the kind of inquiry that we can do in the social and survey sciences. I just want to shout out to some collaborators that have really helped shape my thinking in this area over the last several years. I have some collaborators from Coursera MOOC that I'll tell you about that really helped sort of shape this thinking, along with collaborators on individual projects that I've worked on along the way. So I will say that there's lots in the popular press about big data and the revolution, and even more in AI these days. But I love this quote by Art Connolly and her colleagues, where they say, whilst there may be a big data revolution underway, it's not the size or the quantity of the data that's revolutionary, but rather the revolution centers on the increased availability of new types of data, which have not previously been available for social science research. I really love this idea because it's very possible that we've had these data sets or these data sources around for a really long time, but it's the ability to combine them in data sets to be able to look at interaction effects, to be able to look at how these variables modify or moderate the effects of other variables, that is new. And we have a sort of new lens into generating and maybe verifying hypotheses that we might have had along the way. So I think this is a really interesting opportunity to be working in this space. In 2020, I was asked by a journal to sort of synthesize work in big data, and I did this. I synthesized several pieces of work to really come up with sort of this notion that this big data is really a process rather than a particular size or type of data set. And we think about this as sort of moving from the data generating side to the management side to the analysis side. And so we do a lot of, as social scientists, we sort of have a lot of insight into the big data generation or the collection phase. We also have a lot of insight into processing and analytics, but the idea for the big data piece is that some of these things are coming from non-designed sources. We are discovering this information, we are linking up to fire hoses, et cetera, and these data are coming in volumes, they're coming in quickly, and they require special attention in some of those aspects for generation, processing, and analytics. I also discussed the overall potential of big data in comparison to traditional survey data. You know, it may be all too easy for researchers to discount much of big data. And there's been some of that work in the popular press where people say, oh, big data is really, you know, a lot of hassle for very little gain. And so I would urge us to sort of think about this holistically, though, from the perspective of not throwing the baby out with the bathwater, so to speak, where, you know, much of the appeal of big data as an ancillary source for research is that there may be an inherent value in the information that's mined, and we may not be able to mine it in any other way, or at least in a cost-effective manner. Sensors, for example, can track daily activities of respondents, and this passive approach may actually yield insights into more ubiquitous understanding of a full day's worth of activities for respondents than maybe traditional diaries could do for measurement error, for example. So these kind of automated sort of passive data collection through these devices generate lots of big data in terms of the measures that are sort of collected, but this is a very different perspective in measuring activity, for example. We also, a natural perspective in the big data paradigm, I think in general, is to think about how massive your data set is, this big data hubris kind of idea where my data are bigger than your data because I have 3 million rows and somebody else only has 1 million records in their data sets. I would argue that this is a kind of a misnomer in some ways, because let's say, for example, that my objective was to study men's health, and I have a data set from social media that contains 45 million women. I would think that that data set is still too small to study men's health if you have 45 million records, but they're all from women, for example. So the big data hubris really must be taken in context. And really, I think that it's not necessarily about the number of cases that you have. In the social sciences, we probably won't see those kind of data sets on the regular. But what we do see, though, is that we are expanding our palette for adding and linking data together to get a more 360-degree view of the people that we're trying to study. So we're adding data sets that might sort of encapsulate different parts of a person's life and the things that we want to know about them. And so we're not getting longer data sets, but we are getting wider data sets. And so what's interesting about this is that you know, a lot of analytic techniques don't really work if you have lots of variables and few cases. Think about logistic regression, that would really give you trouble in converging. And so thinking about this big data, both in the sort of the length of the file, but also in the width of the file, I think is really important for social scientists. And so when I think about big data, I'm thinking about wide data sets and lots of variables that I'm able to triangulate and get more information about a particular target population of interest. So these are things to think about as social scientists in the era, and sort of what is it that we bring to the table here that data scientists don't, and how can we collaborate to make this ecosystem much more valuable for everyone. So there's 4 types of big data, sort of 4 categories of big data that I'm going to talk about today. And in each of these, I would like to sort of highlight some advantages to these data sources and some challenges to these data sources, and where we've seen some advances being made in studies around the globe for people who are working with these kind of data. So the first one is the sort of lowest hanging fruit here, and that's the administrative data source. I bucket administrative and open data together, and I'll tell you what I mean by that. Administrative records, I think we all relatively know. Connolly and colleagues in 2016 argued that administrative data is the cleanest type of big data we might ever discover, but they still argue that administrative data is still big data because it isn't necessarily designed for research purposes. It's designed for other purposes and it's neatly organized, but it doesn't mean that it will have everything that we need or that it's actually designed for research. So in that case, it's still considered a big data source. However, it's a tidy one. And open data would be data on the web that we could scrape or access through an API, for example, things like tax records, public listings, housing information, et cetera, and some image data that are also available, satellite image data on the web that are also available through APIs, et cetera. And then we have also population registers that are sort of more of the administrative data type. And these, the availability of these things could vary by country or even continent. And then we have social media data, which are things that are like, we know the social media repositories like Facebook or Twitter or LinkedIn, Reddit, Instagram, YouTube. These are social media pieces. And then the content from those pieces that are original are really what we would consider to be the social media data. So there is also metadata that one could collect, like the number of followers you have, the number of times I retweet, a tweet is retweeted, et cetera. These would be considered what I call digital trace data, which we'll talk about in a minute. The social media data really is data about the people that are on these platforms relative to the content they post and sort of the information therein. The digital trace data, as I mentioned, is things like online transaction data. Every time that you interact with a website, there's a user log that is kept, and that would sort of keep a sort of a linking of the transactions that have happened on that website. And so you've created this digital tail of what has happened, and that sort of those parcels of data would be considered digital trace. There's also internet search data. If you enter information on the internet, this is not original content per se, it's a digital trace of your interaction with the website. And then web survey paradata would be another example of digital trace data, because it really is a popcorn trail of what happened to the user when they were trying to accomplish primary tasks, which was survey data collection, rather than the number of clicks. That's not the primary purpose of you studying them, but it certainly is a byproduct of their interaction with your web interface. I've also put a question mark here because there is growing interest in chatbots right around the globe, and it isn't clear completely where chatbot generated content lies, but people are studying chatbot content and evaluating it. And this is an interesting sort of a dilemma for our field at the moment, is sort of how do we classify or categorize this kind of data, because it isn't generated by humans. All of the other data that we've talked about is really human-centric data, or at least I'm able to trace back to a human. So in a lot of cases. Now, some of this big data could be system-wide, so it's measuring machines, et cetera. But chatbots seem to sort of meet in this sort of middle ground where it's sort of in between. And so right now I'm sort of thinking that this would go under digital trace data, but there could be other aspects of this that would fall under other kinds of data sources. But for now, I'm putting it under digital trace data. There's also sensor data that we've sort of seen a growing number or growing use of sensors being used to collect data more passively. So we have these Bluetooth wearable sensors that can measure things from our health or the number of steps that we take or the kind of fitness activities that we do. There's also accelerometer data. So it's another kind of sensor that we could wear. Remote sensors like satellite images, et cetera. And then household sensors. I mean, if we have like, thermostats that are controlling our our temperature or regulating our climate in our households, these are sensors that are picking up information and recording information and can be useful for that purpose. So the sensors don't have to be worn by humans is sort of the moral of the story. And I'll give you a couple of really cool examples of this use going forward. So I want to talk a little bit about some opportunities for administrative and open data. As I mentioned, Connolly and colleagues in 2016 cautioned that big data should not be synonymous with information collected through the internet, but they made an argument for administrative data being considered one of the big data types. This study in 2015, English and colleagues, I was one of the colleagues, they found that if they used consumer flags from a vendor, so commercially available flags about the household, these flags were looking at whether or not a household had a child under the age of 5, and there were 3 different sources for these flags. English and colleagues found that if they combined these flags in a very important way, they were able to increase the sensitivity of the yields over and above the baseline, which was sort of 19% of households had a kid under the age of 5, and then when they used these flags, they were able to find about 40% of these households, relatively speaking. So the sensitivity of the flags sort of definitely improved and created a much more efficient way to leverage that information in a cost-effective manner. Ten Bosch and al. In 2018 talk about how they used web scraping of open data for the production of official statistics around price indices. And so they were able to scrape common prices of products that were usually measured for their consumer price indices, and found that the web scraping approach created data that were generating estimates that were relatively accurate given what they had done before. Although there's lots of information about how this can be maintained over time because websites change and so on. We'll talk about that in just a minute. I also love this work by Barcaroli in 2016, where they used web scraping to retrieve information about agritourism, and they leveraged that information to update a farm registry in Italy. So they used open web data to update other kinds of administrative data, and this kind of created this update loop that was more efficient for missing data or gaps in their registry. A couple of others here. Data and colleagues in 2020 explored linking data from the 2012 survey of early care and education with commercially available data from the proprietary company called Zillow, and they used what they call the Z-Tracks data, which are publicly available for researchers under a disclosure agreement. So the research team used each of these data sources to corroborate the others. They also leveraged property data from single-family homes and other properties. And this data was available for both their respondents and their non-respondents because this was an address-based survey and they had access to the identifier for the survey. And they were able to do some non-response analysis based on the information of household-related features that they had on everyone that they wouldn't have been able to get commercially through another vendor. So this is an interesting way to think about leveraging these kind of administrative data to help us with ancillary survey tasks like evaluating non-response bias or evaluating survey quality. Every opportunity comes with some challenges. And so I want to be honest and upfront that administrative data and open data, while they have great opportunities, they also have things that we need to consider from a quality perspective. And so one of those would be thinking about whether or not the variables that you need are available. And if they are available, how complete are they? Are those variables time sensitive? In other words, some of these administrative data sets only get updated once a year. And if you have a time varying covariate that you're working with, like household size or household composition, which could change over time, this could affect whether or not you think someone is eligible or not eligible for your study when you try to leverage that administrative data for field work. There's also attributional error when we look at administrative data. This has happened with the COVID pandemic, where in the state of Georgia, for example, in the US, they put all tests for COVID in a single column and reported the positivity rate based on that single column, which contained both the PCR tests, which were the gold standard, and the take-home tests, which were not considered the gold standard. And so they overinflated their true positive rates from COVID as a result of these attributional errors in a single column. And they later fixed that, but they weren't, but really found out later that these were not all tests of the same kilt and of the same accuracy. And so these attributional errors happen, and they happen very commonly in situations where you think they wouldn't. Open web data are volatile. They can change at any time, and webmasters control their fate. And so if you are trying to use open web data for one project and you're doing this annually, expect that the engineering of a website could change over time, and this could be difficult for your web scraper. You might get missing data because of it. And the Ten Bosch article that I mentioned earlier talks a lot about these challenges and really trying to be upfront about what you really need to think about if you're going to architect a solution that leverages the power of open data. On the other side, though, APIs offer a more stable method for accessing the open data, but these APIs are not ubiquitous. Not every website has an API, and not every API is the same. And so if you use an API from Zillow, for example, the creators of that website control exactly what kind of data you can pull from an API and how you pull it. And so not every data field that you would want to scrape, let's say, is available in an API, even from the same website. So these are the sort of trade-offs that you would use here to be thinking about access using these APIs or web scraping. And also one thing to think about for all big data is the fact that we always know that correlation does not imply causation. And so correlation can be spurious, especially if we are connecting all of these data sets together and trying to understand where the signals are. And if we don't design these data, obviously we might be getting signals that we don't completely understand for variables that are not completely well defined. And so we think we have this kind of information, but we're not quite sure if that's really the exact information or what maybe could be a caveat to how that information is being recorded or conveyed through the big data sets. And so this is the graph that I just want to remind you. This graph is titled "The Per Capita Consumption of Mozzarella Cheese in the U.S. Correlates Positively with the Number of Civil Engineering Doctorates Awarded," and the correlation is 0.96. Now, I don't know about you, but in social sciences, if I got a correlation of 0.96, I'm going to be writing my aunt, my grandmother, and my great-grandmother in excitement. And this is probably the cheesiest slide I'm going to show you, but nonetheless, thanks for the forbearance. Now I'm going to talk about some open image data and some challenges here with open image data. So these are images that are available from the web. And I'm going to pause for a second because this video that I'm going to play for you really encapsulates some of the issues. So let me just stop sharing here and I'll share my other screen and hopefully this will work. So just give me a moment here to reset.
Smiles as I bask in their legacies, knowing their lives have altered many destinies. In her eyes, I see my mother's poise. In her face, I glimpse my auntie's grace. In this case of deja vu, a 19th century question comes into view. In a time when Sojourner Truth asked, "Ain't I a woman?" Today, we pose this question to new powers, making bets on artificial intelligence, hope towers. The Amazonians peek through windows blocking deep blues as faces increment scars. Old burns, new urns, collecting data chronicling our past, often forgetting to deal with gender, race, and class. Again, I ask, ain't I a woman? Face by face, the answers seem uncertain. Young and old, proud icons are dismissed. Can machines ever see my queens as I view them? Can machines ever see our grandmothers as we knew them? Ida B. Wells, data science pioneer, hanging facts, stacking stats on the lynching of humanity, teaching truths hidden in data, each entry and omission, a person worthy of respect. Shirley Chisholm unbought and unbossed, the first Black Congresswoman, but not the first to be misunderstood by machines well-versed in data-driven mistakes. Michelle Obama, unabashed and unafraid to wear her crown of history, yet her crown seems a mystery to systems unsure of her hair. A wig, a bouffant, a toupee? Maybe not. Are there no words for our braids and our locks? The sunny skin and relaxed hair make Oprah the first lady. Even for her face, well known, some algorithms falter, echoing sentiments that strong women are men. We laugh, celebrating the successes of our sisters with Serena smiles. No label is worthy of our beauty. Thank you.
Okay, let me just go back to the slides here. So this this really is a summary of this article that appeared in Time magazine in 2019 about this idea that these facial recognition software systems are built on these open images that are available online, and they found large misclassification error rates for darker skinned women as opposed to other races. And so these are just highlights from the video I just showed you, but this sort of speaks to the fact that open data, while it's free and available, may not be completely representative of the populations that we care about. And so algorithms that are built upon that data could perpetuate the bias in the representativity in that data sets or in the available data. So again, this is an issue for the open the data representation piece. And so work has been done recently on the data representatives criterion is one example of this, where looking to assess how adequate training data sets are with respect to these kind of images. The work of Rolf and colleagues in 2021 also rooted in this idea of representation and thinking about how we can leverage better training data to create fewer errors in the sort of output that is that is sort of coming from projects that leverage this open data. Myself and colleagues in Germany are working on looking at sample-based representation metrics from survey research to evaluate potential for biases in training data sets very similar to this other work, and we're relating that back to the idea of fairness in AI. And so some of this work is really trying to acknowledge the fact that there are some weaknesses in the availability of these images and really trying to figure out, or this open data in general, and really trying to figure out a systematic solution going forward and perhaps leveraging some social science techniques for doing that. So I want to transition now into social media data, which we've already sort of defined as the sort of data that's coming from the human sides of these networks, really looking at sort of the actual the content that is provided there, and also who is on those networks. And Burke Garcia in 2018, they explored this is a really great paper on social media data for how to leverage social media data for creating opportunities, not only for sampling from social media sites, but also for recruiting specific populations and understanding a growing proportion of the population who are active on social media sites. One of the interesting parts of this paper is that while social scientists may think to leverage these sites for generating samples, another aspect or perspective is that people who are on Twitter or Twitter users or Facebook users are often becoming a target population unto themselves. And so if I wanted to understand something about the community of Facebook users, I would need to use that platform and leverage it to study that population. It seems like because that population is defined as users of this particular social media platform. And so this is a sort of nuanced view, right? We can use Twitter users to help us understand something about larger populations, or we might ask a very specific question about what's happening to the community of Twitter users, acknowledging that that is a community and there is discourse and there are certain patterns of communication that Twitter users use amongst themselves while they're on the platform. We've also seen examples of papers where, and this is only one of many, where people use targeted advertisements on Facebook or Twitter or other platforms to identify people that are specific of specific qualifications and niche populations or subpopulations, and be able to leverage the social media outlets to recruit those folks where otherwise they would be hard to reach or hard to get or hard to identify. I have a study that just recently is just out of the field, where we looked at how we could use or leverage tweet content to identify possibly eligible people for a particular niche study on digital privacy. And we tested different recruitment methods based on Twitter's direct messaging capabilities. And we pre-registered this study, so you can find out more details at the link. But the idea is that we are trying to leverage the infrastructure of the platform itself to recruit people, and we use the content that people posted as the social media sort of data itself as a way to siphon in or figure out who might be eligible and who wouldn't be. And so this is all kept inside of the social media platform ecosystem. So leveraging not only the platform but also the data in that platform and the way the platform works is a completely is a trend now among sort of the research that is going in this direction for social media. Some challenges with social media has been pointed out by several folks, especially Pew, indicate that, of course, not everyone is on social media and not everybody on social media talks. And so we do see that about 10% of users on these platforms generate about 80% of the social media data that we might mine. So this is a very important consideration here when we think about not only how wide does the Twitter user population go in terms of representing the US, but also how concentrated is that content among a small sliver of folks on the platform itself. The other thing is that the population represented by a given platform may not be well quantified. I do not know completely what a definition of all Twitter users is and how that population of Twitter users might relate back to the US population. We certainly have studies that have estimated this, but certainly the idea is that some of this may not be well known and not well quantified, and we might be missing key aspects of the population like older folks, et cetera. One thing that's really interesting about these, though, is that these platforms themselves do tend to have some personality or some profile about them. We know in general that Facebook users are slightly older. We do know that Instagram users are slightly younger, and we do know that Twitter users are usually politically informed. And so there are different sort of aspects of these platforms that would naturally occur, that would sort of be corresponding to certain demographic types or different profiles that we might expect. Certainly not the absolute pattern, but certainly as a general rule, we've seen studies report these kind of profiles. So thinking about that and knowing that a priori might be a way to overcome this challenge by leveraging multiple platforms that would cover a wider array of the population that you care about. The way you access these data also matter. So there have been studies that have shown that if you use, say, for example, Twitter, there's a couple different ways to access Twitter. There's a streaming API, there's a search API, and there's a fire hose. At least now there is. And so the idea is that if you collected information from one of these versus another, you got very different findings. In fact, wide swings of findings. And this is in part because of the privacy requirements that Twitter has in terms of people being able to remove their content whenever they decide. And so part of this is the difference between a historical look where Twitter has been cleaned and sort of siphoned from people who've said, I want to shut down my account, I no longer want to make it public, and those that are streaming in real time where I'm able to capture information before someone might retract the tweet or decide to turn their account to private. One last thing here is that these social media platforms are engineered. Their job is to improve their services and what they offer to users. So it's completely reasonable that these platforms will change their terms and the way they work over time for improvements or for other reasons. And so we can see this is the case with Twitter, for example, right now, where they're changing different kinds of verifications, et cetera. This happens naturally. And so the one thing that researchers have to be aware of is that these changes happen in real time, and you yourself may be in the middle of the field and have something happen where you're going to have to navigate. And so these are just acknowledgements that these platforms, while we can use them for data collection, they are not designed for that purpose. And so again, this is the found nature of big data or the platforms that are generating this kind of data that we need to be aware of. I want to talk now about digital trace data, and we'll close out with the sensor data. This paper is a really good one that sort of provides a sort of overview of the digital trace data and generating a way to create sort of thinking about error and measurement from digital trace data in a broad way. This other study from Moeller and colleagues, they recruited a panel of participants to install a browser plugin on their device. So sort of this is like a tracker that collected information about users' web activity over a series of media domains. And they allowed this to identify whether or not people were looking at online news. And they found that higher amounts of news use driven by internet searches rather than using an app or using a site, for example. And so Wang and colleagues, they developed a method for inferring demographic characteristics and used them in a weighting adjustment for deriving more accurate population measures based on digital trace data. And this is really important because not everybody on Twitter, while everyone on Twitter has a bio, not every bio is complete. And if you wanted to use or leverage the demographic information that's in the metadata, which would be considered digital trace data, you were not able to, you don't have complete information. So if you're going to try to weight by demographics to try to sort of smooth over this issue of representation on Twitter and project back up to the US population or some other population of interest, and you're going to leverage this metadata around demographics, you're going to find that missing data persists and it's pervasive. And so being able to use this information on the metadata, the digital trace data, and also user content is a really important piece. And so we've seen a couple of different methods where I'm looking at the Twitter content itself, inferring age or inferring education based on sort of reading levels of the tweets, for example, is another way that we can sort of round out the missing metadata, which would be falling under the digital trace category, to be able to do these weighting adjustments. So this is not, the missing data problem is real, and it is more widespread than one might imagine. And so solutions like this one are really important for us to be able to move the needle forward in overcoming some of the representation problems. Some other challenges with digital trace data, as I mentioned, so this missingness is a challenge. The data don't often have information about an individual's behavior or attributes, making it more difficult for estimates of individual level determinants to be derived solely based on digital trace data. We often don't have complete understanding of what every metadata category or digital trace data variable is representing. There's no code book, for example. And so attribution error is real, and being able to trace that back is really important. They also have had some difficulty in reproducing the studies based on digital trace data, in part because digital trace data definitions and availability can change over time. And so being able to reach back and get it and grabbing the exact data that a prior study used is not always easy to do. And then, of course, there are varying degrees of success for predicting demographics. So we talked about the study that predicted demographics, and it varies. Gender is the most accurately predicted demographic, followed by age, followed by political orientation, which is really low on the totem pole based on inferring information from the digital trace and possibly the content of the tweet itself. So this is a combination of digital trace data and social media data being used together to infer some of these demographic characteristics. So again, there are threats to both social media data and digital trace data when it comes to data quality, for example. Again, these platform designers, they design these platforms because of the user experience. And so this idea of homophily, where birds of a feather flock together, if I'm really politically oriented and I really love political discourse, I, like my colleagues who like the same thing, might be naturally drawn to Twitter. We have an expectation that when we share tweets or things on Twitter might be shared that are going to be political in nature, I'm really excited about being able to consume and contribute to that kind of content because I'm a political junkie. So in that case, right, this homophily really comes into play. And so you could be getting this more homogeneous collection of individuals on this platform because of the way the platform is designed and because of the way people on the platform communicate with one another. The other thing is that recommendation systems on these platforms recommend friends that are in your local area and then recommend friends that are in sort of a broader network. And so this idea that these recommendation systems could influence your friend network that appears public on your site is an important consideration because this creates the data that you would otherwise curate from a social media site. There's also like I mentioned, the platform culture itself. This culture may sort of indicate how people communicate. Certain kinds of tweets would not be posted, for example, others might be. And so if we're trying to understand public opinion or discourse, both the good and the bad and the great, we might not see the full spectrum of political opinion just because of the nature of the discourse that is acceptable by users on a given platform. So these are things to consider about sort of topic coverage and sort of this idea of what we would call algorithmic fidelity in terms of does the full discourse of information being sort of captured in the content of the social media data, does it reflect the full discourse that one might imagine if we were to measure it in a different way? And again, these platform technical specifications are also rarely important and can limit the amount of data that one could get. So one of the most interesting examples here are the Google stores information on Google searches, but it only stores the auto-completed version. So if you misspell something or if you type only a portion of it and your digital trace is essentially going to be truncated or it's going to be stored as the auto-completed version because Google is creating these categories in auto-completes and that really drives their main searches and it optimizes the searches for everyone. But again, the digital trace data isn't necessarily going to contain misspellings of Google searches for WAPOR, for example. This just goes to show you that not every tweet or not every Twitter user is a real human. There are bots on Twitter. Twitter is making every effort to reduce the number of bots. And this was sort of a term of the sale to Elon Musk, for example, trying to reduce the number. There will never be a Twitter where there's zero bots, I think, because there are these whitelisted bots where people care about the weather or traffic. They generate content automatically. But again, you can see that lots of the followers and some of these are some of the most popular Twitter users with in terms of the number of followers they have. You can see the proportion of their follower accounts that are fake isn't a negligible number. So there are fake accounts, and what we might be studying is data that are generated by those fake accounts in addition to the humans. And so these are things that we have to take into account. And there are bot detectors that can be used, but those vary with success and require certain amounts of metadata to be captured. So these are things that are important to consider. And then, of course, there's the Google Flu Trends study. I'm going to skip this for now because I want to get to the other the other piece. But one thing to note here is that the Google Flu Trends was a digital trace experiment that worked for a while and then it didn't work. And then other researchers have later improved on this, where they basically used CDC data and Google Flu Trends data together in concert. And the combination of these two data sources actually created an estimate that was better than either of the sources separately. So this is the really exciting part about the combination here. And so you can look at this where you can see that the Google Flu Trends data is in red. That didn't do so well here. The CDC data is in blue. That does okay. But if you look at the combined data, it does even better. And so if we can evaluate this, you can see that the overall sum of squared errors for the combined data was smaller than the either of the individual data sources. And this is a way where we can think about leveraging the power of not just one data source, but multiple data sources and different data types to round out what is being represented in a way that actually improves the estimates. This is a kind of exciting frontier and really, really a big advance in the Google Flu Trends dilemma, at least early on. I want to talk about some sensor data here before we close out. Again, sensors are useful for passive data collection, and we can scale this. So one example was English in 2020, where they used data from 140 sensors that were placed throughout Chicago to investigate how air quality affected chronic health conditions. Illich and colleagues in 2020 collected picture data of the general population using smartphone sensors. And they discovered that folks were willingness to take pictures, and about 88% of the pictures were in line with the request. So they were able to get or capture this kind of data using essentially the camera on someone's phone, which could be considered a sensor that is operated by a human. We've also seen some GPS location data be useful. What's really interesting, I didn't put this example here, is in the Netherlands, for example, they have replaced I believe this is the Netherlands, they have replaced travel surveys for official statistic generation by statistics that can be generated using road sensors that are measuring traffic patterns using the road sensors. And then they have a smaller travel survey that rounds out some of the estimates that they need. But this idea that these sensors are really able to automate and generate these official statistics or other measures of quantities that we care about at scale is a really interesting direction that we see lots of people, lots of work in our space currently. There are some challenges with sensor data, though. I just want to make it clear that data access in some of these cases requires consent, especially among human populations. And so people would have to consent to having their smartphone be tracked, or using their cameras, or using information that are available to researchers, or being compliant. So it's not only the consent, but it's also the compliance. Do I wear the sensor? Am I wearing it as frequently as you want, et cetera? Smartphone sensor data from smartphones, for example, may be missing for various reasons. Individuals run out of battery. They don't notice that the tracker on the phone is putting a drain on their battery, and so they don't charge their phone as quickly. So some of the data that would be collected, in a sort of continuous manner may be truncated in the data file because the phone died, for example. Or they have no signal, so the tracker requires some sort of communication with the server. If that signal goes down, the communication is blocked, and so no data are collected for certain periods of time, or other specifications. Sensors might be You might also get raw sensor data problems where I wear the sensor in the wrong place. I put it on my shoe as opposed to my hip. So measurements from me about my motion could be skewed relative to somebody else who's wearing the sensor properly, for example. Here's an example where we look at what's being done in Boston, and I'll talk just briefly about this in a second. So I'm just going to play this, for example. Let me see if this will work. So this just gives you another example of how sensors can be used. What's really interesting in the Boston example is that often neighborhoods where there are lots of potholes are neighborhoods where there aren't very many people driving cars because it's very expensive to own a car in Boston. And so using this sensor on your bicycle, for example, is a lot harder than using it in your car. And so there could be coverage issues and so on associated with these sensors. But again, this just gives you a sort of flavor of how this could be useful and how it is being used currently. I wanted to end today with a conversation about some resources for thinking about big data quality writ large. I think we've sort of given you kind of an overview, a sort of very quick trip down sort of 4 main categories of big data. We've seen where people are leveraging the power of them. We also have acknowledged some of the limitations. And so when we think about how to work through these limitations in our own research and figuring out if it's worth the effort to use these big data, I think it's really important to be grounded in some error frameworks. And so there have been a couple of these that have been developed in recent years. The total data error framework by Amaya, Beamer, and Kenyon. I would argue that this framework is really considers error from survey and non-survey sources in a sort of very generic way. This is a very sort of wide sort of applying framework. It doesn't necessarily attend to the idiosyncrasies of each data type, and it also doesn't necessarily give you a clear path from every kind of data error that you could get in the big data all the way to survey error. That's a really hard line to draw, but it is a start in thinking globally about all the errors that one could encounter. I think there's some recent work that have been done by Brady West and James Wagner and colleagues, where we look at this from a total data quality perspective, where we really have tried to use the total survey error context and really draw sort of at least dashed lines between errors that you can get in the big data sources and errors that we get in surveys, and trying to sort of equate them in some ways, at least through these equivalence classes, so that you can really start to understand how to leverage or evaluate the quality of a proposed solution that might incorporate multiple kinds of data sources. So we looked at both the design data piece and gathered data piece. And then there's an upcoming special issue of methods, data, and analysis that I would like to bring your attention to that's looking at using big data sources for solving social science problems. The really cool part about this special issue is that it's going to be, of course, peer reviewed, but there's going to be a every author will submit a peer edited appendix that details a reflective way, sort of in a authors are going to be doing a sort of guided reflection that is peer edited, that will sort of highlight the choices that they had to make and the methods they used to overcome some of the limitations they experienced in real time in working with these alternate data sources. It's completely possible that you and I are working on a study 1 year apart, and I am encountering something totally new because the platform changed their architecture. So I have to use all the methodological understanding and methods that I have available to me to overcome that if I want to persist in my research. This article is going to document not only the findings of the research, but also the ways in which the researchers had to navigate that in a guided way. So I think there's going to be lots of insight that's going to be generated from this special issue. So please be on the lookout for that. There's also, as I mentioned, this Coursera specialization in total data quality. So if you are so inclined, you can check this out. There are 3 different courses thinking about how to sort of define data quality from a holistic perspective. There's also how do we measure data quality, and then how do we sort of optimize or fix it, sort of fix problems with it. So this is the sort of the idea. So we've sort of covered 3 bases in this Coursera specialization. So if you're interested, you can check it out. And so I wanted to sort of close with this. Big data sources offer a lot of opportunity for survey researchers and social scientists in this 4th era of survey research, where we're seeing lots of combinations of data sources taken together to solve problems in an era where we have smaller budgets and we have higher non-response. Their use is certainly not without concern, though, because we know that we've seen some challenges with these data sources. Reproducibility and representation are among them. And some of these we can't completely control, but we can try to at least identify where the threats in the quality might exist. We also may not have statistical methods that are going to really bear out the big data sources that we have. I mean, if you just look at visualization and try to do a scatter plot using 1 million points, you're going to get what I call the scatter blob, and that's not going to be very insightful. And so we have to think about ways that we can leverage machine learning and other techniques to sort of maximize the utility of these data sources. There is a book chapter by Antje Kirchner and I that we talk about all the ways that machine learning can be leveraged in the survey research process. And there's about 250 references there to talk about how many people are doing this in our field. And so that's really exciting. It's sort of an exciting frontier. So I would encourage you, as you're sort of moving forward, don't let the challenges block you from thinking about the potential, but don't also go into this with blinders on. There are considerations that are real and they have implications for our work, but it doesn't mean that we would necessarily need to dismiss these opportunities writ large. I think if we think about this from a total error perspective, and we use and leverage our skills in the social sciences and survey research area, we can holistically determine whether or not some of these sources might be fit for purpose and how we can leverage them in a responsible way. So I just wanted to also give one shout out to the Big Surf Conference, which is happening this fall in Quito, Ecuador. This is a place where people are combining these kind of data sources together and really stretching the envelope on what is possible in our field. And so if you are so inclined to are interested, this is a global conference. People come from all over the globe. There are travel funds available if you need them. And so just check it out. This is a great opportunity for you to learn and maybe contribute to how people are using big data sources around the globe. I close with this. After big data solves all of our problems, we'll ride away on magic flying unicorns. So thanks again for your attention, and I'm really thankful to be here. Happy to entertain questions.
Terrific presentation. Thank you very much, Trent. It is a great overview of the opportunities and I think the challenges as well. I'm inviting our participants to start posting their questions. I've got a couple myself, but let's go right to some of those that we see posted. Tim Van Blarkham asked the following, Trent. What are the implications from the rise of GDPR and other similar data privacy legislation around the world on big data? Is this going to make administrative record linking more difficult and increasingly risky for researchers? How do we work around and think through that?
Yeah, this is an interesting one because the GDPR has had implications for the US and other places too. With any company that does global commerce, they have to sort of meet this requirement all over the globe. And so I had a study, we have a study that we're just finishing now where we used Facebook to recruit hard to reach minorities. And we also used Google Analytics to track the path from the advertisement on Facebook all the way to the completion of the survey. And because of the cookies along the way that people have to accept when they get to our sort of study enrollment website, which is where the Facebook ad takes them, we found that about 20% or so we couldn't track all the way from the ad to our survey completion. So we lost, there was a huge data loss there from the Google Analytics that were going to be our inferred demographics for the non-respondents, for example. So, so this is a piece where we do experience some data loss, and we do have to think about what consent looks like in that arena when we're moving across these different domains for recruitment, because people are going to, they're on Facebook already, they've accepted those cookies, but when they get to a new website, a cookie is presented and they're asked for permission, and people may not give the permission, especially if it's taking them outside of the ecosystem that they feel comfortable in. So trust is important. Communicating what that study is, communicating that they might go to a different website so that they can accept cookies and feel safe is an important piece. And so I think GDPR has made this awareness greater among people who are collecting or who for whom data might be collected on the internet. And so just like before, where you have non-consent missing data from people who don't consent, you're going to have this from cookies too. And so the consent language is really important, and work to consolidate consent language and make it more clear is really important. And also linking. I'll give you one more example about the linking piece. I had another study where we linked administrative data to survey data, and we asked people permission to link the administrative data, and we explained why. And there were three main variables that we were trying to get from the administrative data, among others. But for those people who refused consent, we asked those three questions immediately in the survey. So we anticipated the implications of non-consent for the linking, and we tried to capture in real time those variables. So it was kind of like a non-response follow-up study, but it was really for non-linking. And otherwise we wouldn't have been able to leverage their information along with the information that we collected from everyone else. So these kinds of data collection habits are going to be needing to be fleshed out and optimized as we move forward in the era of cookies and the GDPR. At least that's sort of my small take on the problem.
Thanks for that, Trent. I'm interested in representativeness, among other things. I wanted to ask, why and how could we expect that big data of the kind we're discussing, whether it's administrative or found social media data, why and how can we expect that it may be representative or generalizable to any population beyond the participants?
This is a good question. There's a new article that literally just came out last week that looks at comparing human discourse for political topics and the discourse that one can generate using ChatGPT. And they found that in large part, ChatGPT was able to recreate the complexity in the human conversation, in part because ChatGPT was created using content that was provided by humans on the internet, right? And so the idea is that if there is some underlying model that we would expect that governs how people converse, or that governs the biology, if you exercise, you're going to maintain your weight or something, then representation may not be the driving force that we need. What we need is sample size to estimate the parameters of that model if that model is ubiquitous. And so understanding when models are ubiquitous is a really important piece for when we ask the question about representation and when we ask the question about sort of the capacity to estimate. And so this is where I would say the political science example really talked about the fact that it doesn't matter who you get. This political discourse has certain rules or tokens of exchange, and they were able to reproduce that without having a representative sample. But it was because this discourse has been so well documented in the history of political science discourse that it's a pretty known phenomenon. And so it's not one that you necessarily have to worry about representation as much as you have to worry about sample size to be able to estimate all the nuances of the phenomenon. Other cases, right, where you care about specific subpopulations, right, where maybe you care about African Americans and their opinion about the electorate or the electoral college, for example, This is something that isn't necessarily model-based and something that you will need to have representation in order to generate estimates that are going to be sound. So I think this really depends on the context, and I think it also depends on whether or not we think that there is this something systematic that can drive this, where I'm trying to estimate the model and explain that, or whether or not there's a new thing that I don't know, and I really want to get all people's perspectives involved.
Really interesting. Thanks, Trent. So another of our attendees asked, do we have methods to solve these challenges for big data? And I'm assuming the challenges being referred to there are the quality control, the data quality challenges. And so, you talked about administrative data being among the most reliable, but I remember a paper by a guy named Matt Barrett, who's a student of John Krosnick's back in the day, who talked about, they tried to validate voter registration data, and he found a lot of flaws and errors in the source data, in the administrative data. People were 140 years old, a lot of people born in 1900 because it just got filled in that way. So you have problems with administrative data, and then with open data, you mentioned yourself, risks of manipulation, of falsification. Is that 20,000 people or one person clicking 20,000 times through a bot? And you then just now mentioned ChatGPT, which raises a whole nother world of issues about validity and reliability in the data that are collected here, since they're found rather than purposefully produced. So how do we deal with the QC issues?
This is a huge problem, and this is one of the reasons why we actually created the Coursera MOOC, because people have been asking these questions quite a bit, and we sort of tried to take a positive spin on this, where we were looking at total data quality and sort of realizing that, some of this quality, there are quality issues. There are ways to maximize the quality, and there are ways to that we just can't. And in part, this really depends on the type of data and also the type of scenario that you're trying to investigate. Whereas, what might be the solution? So, for example, in the Google flu trends example that I gave, they found that, if we leverage the CDC pre-estimate with Google Trends data that was collected in the same week, and we leveraged it in a certain way mathematically, we could actually optimize the estimates. And so the solution here was to not take Google flu trends data on its own, and not take the CDC pre-data, because the pre-data we know has errors as well, because it's the pre-data. It's like the quick and dirty version of their estimate. It's not the final version. And so if we take both of these slightly dirty estimates and somehow combine them, we seemingly get a better solution. And so in that case, the solution was to combine information. Other solutions might be to corroborate the data sets, or to think about how to replace missingness, or to leverage missingness as its own category. Oftentimes, administrative data sources are really bad at completion. Not every data cell is complete, so you have lots of missingness. But the missingness itself can be a signal. So rather than try to fix it with a Band-Aid, we actually just leverage that signal and let it speak for itself. That's another way that we've sort of seen how we could leverage that information, for some utility. It's true that we don't design all these things. And so the solutions of these things are going to be, some of them are going to be post hoc, some of them are going to be through processing or post-processing, and others are going to be through better keyword specification. If you try to look at the Google flu trends, for example, if you look deep down inside, one of the reasons why that failed is because the keywords they used for detecting flu trends had things like basketball in them. Because every year, March Madness corresponded with the peak in flu season. But now that March Madness is creeping into April, that doesn't work very well as a keyword. And so this spurious correlation got worse as the basketball season expanded. And so this is just one example where you're like, well, if I change the keyword specification, could I improve the overall estimates? So understanding how to access these data is another piece where we might be able to see some improvements. There isn't a one-size-fits-all solution, unfortunately, but I think this is why it's exciting, because social scientists know a lot about data quality, and we have a lot of solutions. We can actually bring a lot of this to the table, and I've seen some examples of that, even the stuff I've talked about. So to me, that's kind of exciting. No, it's not the answer that we want to hear, but it means there's opportunity for us in the future.
Great. Trent, another question comes up from one of our participants. who who asked how would the part of the population with no internet connection influence research? This participant raises this question about digital trace data, but it's true more generally as well, of course. And it's not only about internet access, online access, but also about literacy. All right, there are many countries around the world with very large non-literate populations. How do we deal with that? And are we skewing our research toward digital elites? Is that a concern?
Yeah, that's certainly a very valid point. I mean, we even worry about this point though in the survey space too, where a lot of our more cost-effective solutions are relying on web data collection. Whether it be through non-probability or probability sources, that really isn't the main concern. The main concern is coverage. And does the non-internet population differ? I mean, I have a paper with David Dutwin that appeared in 2022 that really deals with this very issue, that the 10% of the non-internet population is very different in the US at least than the non-internet population in marked ways, and that we might care about measuring. And so developing these propensity models for adjustment is one possible way we can do this. We have seen some of this done in the digital trace space, but the metadata isn't as complete as it is in the survey data. So being able to form these propensity adjustments seems like a reasonable solution, but practically speaking, it's not as easy because we have a lot of missing data in the digital trace space. As large as that data is, some of it's really missing, and the important pieces can be missing. So another piece of this that's important to what you said about the digital elites is, I would say also that if you think about the content that's generated on social media, it's highly concentrated by a few contributors. So we see lots of content being contributed by very few users. And so this also raises points about the representation and the sort of projectability of that. I think, again, this is context specific. We might find that in some cases, you can get really good sort of tracking of digital trace data because we care about digital transactions. So we're already sort of constraining our target population to those people who might be on the internet. So for example, people might want to know, when people buy items on Amazon, does the recommendation matter? And we want to look at digital trace of people's transactions. Well, that population is well defined. And so I don't really care as much in that problem about the people who don't have Amazon or that don't have internet, because they aren't part of the target population. Other studies, though, might want to leverage leverage these data for projection to the whole population. These are things that we have to sort of take into consideration.
Really interesting. Good. Thank you. I want to encourage participants who've got further questions to go ahead and post them. I did want to ask one, Trent, because one sort of related issue, particularly with social media, not so much with administrative or source or censor data, regards to content analysis. And on social media, attitudes are expressed with irony, slang, hashtags, emoticons, all sorts of complex language and symbols that may not be that simple to decipher. And I've seen presentations that show content analysis packages, different packages produce very different results in terms of extracting meaning from social media posts. How do we think through and handle the whole issue of content analysis, which is another piece of this, I think?
This is the $1 million question. I really love this question. Thank you for asking, Gary. So a couple of things here. There's a paper by Pasek and others in POQ, and I think it's 2016 or 2017, that talks about how tweets that express public opinion and public opinion that is expressed through, say, survey items aren't really the same thing. Even though we could be capturing a similar sentiment, we are not necessarily, volunteering information on Twitter is one thing, being asked about your feelings is another. And so the idea of sort of understanding the differences in terms of what each could measure is a really important piece. And then Conrad and colleagues in 2022 had a presentation at WAPOR last year and some work coming out that is talking about alignment. So it takes that concept one step further, and it asks the question, when given that we know that survey items and tweets are not necessarily the same thing, when, though, can we see that they align in terms of what the measurement properties that come out of there, and what topics are really getting better alignment and what topics just don't? This creates a way more efficient pathway for survey researchers to say, in this lane of questions about, let's say, health literacy, you need survey questions because the social media data does not align with the concepts that we are getting around this measurement. And the alignment is off. And so where the alignment is off, you really need to rely on one method over another to optimize understanding or to reduce measurement error. And so there's work around sort of this acknowledgement that the social media data is different than survey data, even though we might be measuring similar things. And then this recent work by Conrad and others that looks at sort of when these concepts align to be able to be useful, to be exchangeable, so to speak, when we can generate estimates that might be okay from Twitter versus something on a survey. I think this work really speaks to the future of what we might be doing in our survey space to more, to sort of leverage the power that surveys bring that are different from social media, and being able to recognize those differences is part of this emerging research. I know this doesn't answer the question entirely, but it does give you a glimpse into the future of what we're learning.
Yeah, there's a lot more to learn. It sounds like. I've got one more for you, and I'm going to also, before I ask it, I'm going to make a last call to our participants for any further questions you've got. Time to post them is now. John, I'm just wondering how confident we should be in estimates using big data in the future. When you talk about Google Trends and the CDC data, that analysis seems as if it were fundamentally post-dictive, to use Edward Tufte's phrase, in that we know what the flu incidence was, and now we're using the data that were produced to predict it and seeing if what works best in terms of predicting an outcome that we're aware of, which is flu cases. I don't know how confident we can be that that in fact would work in the future. And in fact, as you know, Google Trends by itself worked until it didn't. So in that case, and then more generally, not thinking post-dictively, but predictively, how and why should we have confidence in these approaches?
Yeah, I think that this is another important question, and one that I think we're still sort of dealing with, right? And the idea of the big data hubris is still among us, right? That, you have these studies that come out and they have, millions of records, and they leverage the power of 1 million records. But in fact, 1 million records could be too small to study complexities of a population. If you have 1 million records from all men, for example, and you're trying to understand the complexities of modern society, I think these are things that we have to sort of think about. And what I see sort of going forward, at least in the immediate future, is not necessarily a solution or an answer to the question you posed, but more so a responsible consideration of the potential of these data sources in combination with one another. I think we've seen a lot of success in thinking about combining or leveraging these utilities together. So for example, social media has been shown to be a really cost-effective and great outlet for boosting participation among harder to reach populations, in addition to a survey that's a probabilistic survey that just cannot, for whatever reason, get into those places to survey folks. And so we've seen this kind of judicious use of the two methods together. I think the CDC and Google Flu Trends is another example. We've also seen greater transparency being coming up, where people who do a study with social media or with digital trace data are now prescribing from sort of, say, the total Twitter data error framework, for example, what keywords they used in the search, so that I could at least understand if those keywords cover the topic that I'm interested in, or whether or not I thought the researchers might have left out very key and fundamental keywords, so that allows me to evaluate corpus. It allows me to evaluate the findings and consider caveats to that. And I think this is really the next sort of step in our work. I don't think we're going to replace survey data with big data. I also don't think that big data is going to necessarily stand on its own very soon, but we are seeing these frameworks that are helping give more responsible consideration of these data sources, and in an honest way. I think that's a really important piece because we are all living in an expanded fit for purpose paradigm. We don't have more money for our surveys, we have less. We don't have more respondents, we have fewer. So we are faced with these decisions, but we must also think about in this sort of fit for purpose paradigm, how do we do this in a responsible way, in a way that's going to, I think, shed the best light in the questions we're trying to ask. So this isn't a one size fits all solution, but there are approaches that are emerging that acknowledge the totality of these data sources in concert with one another and thinking about the potential and the error.
Yeah, and I think where you're going with that is toward a topic that's near and dear to my own heart, which is transparency, right? And I take it you'll agree that by really fully disclosing the data and the methods used to collect and analyze the data is really the only way that the research community can evaluate research claims and come to some consensus on their reliability and validity. So are you seeing the sort of transparency we need in the analysis of big data to date, or do we have room to grow in that area?
It's a really interesting thing. In one of the short courses that I offer in this topic, I talk about this to students a lot, and that is this idea that there's an acknowledgement in the literature for big data, especially, that a portion of the very precious pages that you allow for research publications should be completely committed to reproducibility aspects. So in other words, how can you retrace my data popcorn trail? How in terms of keyword specification, in terms of declarations to respondents, in terms of how you actually collected or manifested this corpus of data. The issue is, so I'm seeing a lot more progress in that direction. I'm not necessarily seeing as much progress in the sharing of the data because it comes from multiple sources that are proprietary, or the found nature of big data doesn't always lend itself to public availableness. But if I'm able to give you a popcorn trail and a synopsis of how this data corpus came to be or came to be accessed, at least it gives a better critical lens into some of the caveats that might be needed in acknowledging the limitations and the strengths of that sort of data resource as part of the overall solution in the research that's posed. So I do see some progress in the direction of acknowledging these data sources and access. It's harder, though, for the data sharing piece for obvious reasons, for the third-party nature of some of these data. But that's a problem that will probably stay with us for a while because not everything is open source, unfortunately.
Great. Okay, and one more question came in. We'll maybe make this the last. We're getting toward the end of our time. Samir Abu Ruman asks, when we say big data and artificial intelligence, what's the difference regarding measuring public opinion? How does AI, the buzz of the last few months, play into the whole big data discussion? Have your thoughts on that?
Yeah, so I think that we could separate big data and AI first by saying that AI is typically an algorithm that can be applied to big data. And so we can actually use that algorithm to generate estimates, or we can use it to generate more data, like in the case of ChatGPT. But big data itself doesn't necessarily need AI to process, right? We use big data in our survey data, like think about survey paradata that we collect by respondents. We use mouse clicks or time that a respondent takes to answer questions to identify speeders. And that's a quality indicator that we can derive without AI. We can derive that using simple statistics, but it's considered to be big data or digital trace data, if you will. That's sort of a category of big data. So I would say that big data are data. AI is a method that can be applied to data to generate more data or generate insights or generate estimates or predictions. So AI is a method, and big data is a thing that we can actually use or leverage. And so I would say that ChatGPT is an example of where AI is being used along with big data, because there's obviously training data that goes into it, to generate more data. It's a generative algorithm. So we're seeing lots of talk in the common press now about generative AI. Generative AI are AI that take a big data corpus, use some machine learning algorithm, and they generate more data. They generate data that we can see in front of our faces in terms of these, outputs from the ChatGPT sessions. that would be considered, AI data or generated data, hybrid data, digital trace data-ish kind of stuff. This is a relatively new occurrence in terms of the taxonomy that I talked about today, but that's how I see the difference. I see that AI can be used to generate data. It can also be, it requires data in order to work. Big data can stand alone. We can use it for estimates. We can use it for models. We can use it for tracking, et cetera. We don't necessarily need AI to process it per se.
Great. Well, excellent presentation. I'd like to say, in addition to your own insights, your review of the literature are super helpful. And I want to point out to our participants that the recording of this webinar will be available on YouTube via the WAPOR website, so you can go back and check those references. I just want to say thanks to our participants, thanks to WAPOR for its sponsorship of this webinar, and above all, thanks to you, Trent, for your time and your expertise.
My pleasure. Thanks, everybody.
Take care all.